Okay, hey everyone. This is going to be my first video lesson with you guys. So what we're going to be working on this week is we're going to be going through the number sense and algebra review package that was handed out on the last day of class. Okay, so my plan is to go through a couple questions every day and just work our way through this package as we go. Okay. Okay, so what I want from you guys is I would love it if you had your package in front of you and that you worked along with me. Okay. And I'm also going to suggest that you pause the video at certain times and try to attempt the question on your own before viewing my solution. Okay. All right, so let's go to question number 1. You can see that I've separated each question so it has its own page so that I can show my work. Okay, you guys don't have this, but you guys can use rough paper to do your calculations. Okay, so question number 1. The average temperature during 10 days in March is given by the expression 6 times -2 minus 5 plus 3 times -1 all over 10. Okay, what is the value of this expression? Okay, well, we can see that this is a question where we have to follow order of operations. Okay, so that's what we're going to do. So I'm going to remind you guys, right, order of operations, we always start with whatever's inside any brackets. Then we work with exponents. Then we do division or multiplication, right? Whichever one happens first. And then finally adding or subtracting. So that's the order we're going to go in, okay? So if we look at this expression, well, there's no brackets, there's no exponents. Well, there's brackets, but we can't simplify in the bracket, right? So the first thing we're going to do is we're going to take care of this dividing, the multiplying that's happening. All right, so I'm going to just set up an expression here and I'm going to go through it. Okay, so I'm going to leave the bottom as 10. I'm not going to touch that. And I'm going to do 6 times -2 first. Okay, so that's -12. Okay, I'm not going to do anything about the -5, right, because I know subtracting comes later. So I'm just going to leave that as -5. And then I'm going to do this multiplication. So 3 times -1, well, that's -3. Okay. All right, so now I just continue to work, okay? So 12 minus 5 minus 3, right? That's going to give us -20, okay? Remember, we have to do this first because technically there is a bracket around the top of the fraction bar. Okay, and then we have divide by 10. Okay, so when we simplify, this leaves us with -2. Okay, so therefore, right, the average temperature during 10 days in March was -2 degrees. Okay, so we circle that as our final answer. Okay, so that's question 1. Let's move on to question number 2. Okay, so again, this is order of operations. So we're going to work on this again, right? So in this expression, right, we have 5 times -18 plus 12, right? We have -18 plus 12 in the bracket. We know that we have to simplify in the bracket first, so that's what I'm going to do, okay? So I'm going to leave the 5 as it is, and I'm going to simplify. So -18 plus 12, that will give us -6, okay? Then on the bottom, well, on the bottom, I can combine those terms right away, okay? So I can do -4 plus 1, right? So guys, remember, when you're working with adding and subtracting and you're working with negative numbers, right? Just a reminder, you know, sometimes it's a good idea to think of a number line, right? When we're adding and subtracting negative numbers, okay? So, for example, oops, need to go a bit further, -4, right? So if I'm at, let's see, if I'm starting at -4, right, and I'm adding 1, remember, I'm going this direction, right? So I end up at -3, okay? That's just a little reminder, okay? So, oops, oops. Okay, so we'll leave -3 down here, okay? All right, so now we continue to simplify the top of our fraction bar. So we get -30, right? 5 times -6 is -30, divided by -3, okay? Now remember, a negative divided by a negative gives us a positive answer, okay? So that means we get a final answer of 10, positive 10, okay? So therefore, right, the value of the expression is equal to 10. Okay, good. Let's try the next one. Okay, 3. What value of m makes the equation 6a exponent m over 2a exponent 3 equals 3a exponent 5 true? Okay, well, this should remind you of exponent laws, right? Okay, so I'm just going to look at the left-hand side of my equation here, right, where I have 6a exponent m over 2a exponent 3, okay? Now, I'm going to simplify the left-hand side of my equation, okay? So, oh, sorry, and that's equal to 3a exponent 5, okay? So now I'm going to simplify the left side, okay? So I'm going to start by simplifying my coefficients, right? So 6 divided by 2, well, that's equal to 3, right? 3. And then here we have two exponents that have the same base, right? They both have a base of a. So we know we can use the exponent laws to simplify this, okay? And this is where we have the quotient law, right? So remember that if we have a exponent n over a exponent m, right, that simplifies to a n minus m, right? Okay, so therefore, if we have am divided by a exponent 3, we can write that as a to the exponent m minus 3, okay? And then that's equal to 3a exponent 5. All right, so we're just going to continue, simplify, right? So again, I'll divide both sides by 3. In doing that, well, that just cancels out my 3's, right? And I'm left with a m minus 3 is equal to a exponent 5. All right. Well, that's good. Okay, so we have the same bases on both sides of the equation. So the only way that our equation can be equal is if our exponents are equal, right? So if this is true, if this is true, right, then doesn't it follow that m minus 3 has to equal 5? Okay? Well, now we have a simple equation that we can rearrange and solve for m, right? So remember, we rearrange the equation by moving it to the opposite side and getting m all alone. So I end up with m is equal to 5 plus 3, which finally gives me m equals 8. Okay, so why don't we just test that? Let's test our answer, right? So I think the answer is m equals 8, but let's check. All right, so I'm going to take the expression 6a exponent 8, right, because that's what I think m is, divided by 2a exponent 3. All right, I'm going to simplify this and see if it matches 3a exponent 5. Okay, so again, simplifying the coefficients, I get a 3, and then I get an a, 8 minus 3, which does in fact equal 3a exponent 5. Okay, so therefore, right, that means that our answer has to be correct. So the value of m that makes the equation true is when m is equal to 8. All right. Okay. All right, excellent. So question 4, Meg has been asked to determine the value of the numerical expression below. Which of the following is the value of Meg's expression? Okay, so essentially, right, what we're just doing here is we're simplifying our expression. Okay, now remember, so we have to work to use our exponent laws again, okay? So first of all, I see that we can use the quotient law again, right? Where we have a exponent m over a exponent n, that's going to equal a m minus n, right? The quotient rule. So I'm going to use that to simplify the first term in this expression, right? So 2 exponent 400 over 2 exponent 396, okay? And then I'm going to leave the second term alone. Just leave it like that. It's a minus. Okay, so here, right, within here, I'm going to use my quotient law. So I get 2 exponent 400 minus 396 minus 2 exponent 3. Okay, well, 400 minus 396 is 2 exponent 4 minus 2 exponent 3. Okay, so here's where some of you may have made a mistake, okay? There is no exponent law for adding when adding exponents of the same base when we're doing subtraction, right? Because remember what exponents mean. They mean multiplication, okay? So there is no exponent law that would simplify this expression, okay? So what we have to do is we just have to, solve. So what is 2 exponent 4? Oops. Well, 2 times 2 times 2 times 2, 16, right? And then what is 2 exponent 3? Well, that is 8. Okay, so we end up with 16 minus 8 is 8. And that's our final answer. So, which of the following is the value of Meg's expression? Well, the correct answer is D. Okay. All right. Okay. Question number 5. All right. So, it says if x is equal to 3, what is the value of 2x squared plus 5x? Okay, well, this is a question where we just substitute the value of x into our expression. Okay, so I'm going to start off just writing the normal expression, not changing anything, 2x squared plus 5x. Okay, and now I'm going to replace each x with the number 3. Okay, so 2, oops, silly. How do I undo? It'd be good if I knew how to erase. Here we go, I think that erases. Yeah, good. Okay, so 2 and then 3 to the exponent 2 plus 5 times 3. All right, so now we follow order of operations, right? So the first thing we do is that exponent. So this becomes 2 times 9 plus 5 times 3. All right, 2 times 9 is 18 plus 5 times 3 is 15. All right, and this gives us 33. Okay, so the value of 2x squared plus 5x when x is equal to 3 is 33. 33. Okay. All right, 6. What is the value of 6x squared when x is equal to 1 over 3? All right, so same idea as the last one. All right, so I'm going to just rewrite the expression 6x squared. And I want to replace the x with 1 over 3. Okay, so I get 6, 1 over 3 squared. Now remember, when we have exponents and the base is a fraction, we just distribute that exponent to the top and bottom. So we get 6 is equal to 1 squared over 3 squared. Okay, so that's equal to 6. Well, 1 squared is just 1, isn't it? Right? 1 times 1 is 1. 3 squared is 9. So I get 6 times 1 over 9. All right, now I'm going to do some cross-simplifying. Remember cross-simplifying? Okay, so I know that with between 6 and 9, right, I can rewrite that as, 2 over 3. So my final answer, right, the top would be 2 times 1, which is 2, and the bottom is 3. All right, so there we go. So the value of 6x squared when x is equal to 1 over 3 is equal to 2 over 3. Good. Number 7. More exponent laws. Okay, so what is the value of x squared raised to the exponent of 3 when x is equal to 1/2? Okay, so again, I'm going to write the expression back out. So x squared all to the exponent 3. So before I plug in my value of x, I'm going to use exponent laws, right, to simplify. Okay, and what exponent law do I use? Well, you remember the product of a power rule, or sorry, the power of a power rule, where if we have a exponent n all raised to the exponent m, we get a exponent n times m. Okay, so that's what I'm going to do here. So I'm going to do x, well, 2 times 3 is 6. Yeah. Okay. Just so you know, a common mistake that I see here is that students will think that they need to turn it into 2 exponent 2 raised to the power 3, and they turn it into x exponent 8, right? Well, that's not correct, right? Remember, we're just multiplying. Don't do that. Okay, so now that I've simplified with exponent laws, now I'm going to substitute in my x value. So I'm going to put in x equals 1/2. All right, so 1/2 exponent 6. Now again, I'm going to distribute. I'm going to distribute those exponents. So 1 exponent 6 over 2 exponent 6. Well, 1 exponent anything is just 1, right? 2 exponent 6 That, I believe, is 60. Now, let me double check. Yeah, it's 64. Okay, so our answer is 1 over 64. So the value of x squared to the power 3 when x is 1/2 is 1 over 64. All right, we'll do a couple more. Maybe we'll go up to question 10 today, and then I'll stop and we'll save the rest for another time. All right. Okay. All right, more same. So what is the value of the expression x squared when x equals 4 over 5? Okay, so let's just start by writing the expression. And then I can't simplify, right? There's nothing to simplify here. So now I'm just going to go right ahead and I'm going to substitute the value of x in. So I get 4 over 5 raised to the exponent 2. Now remember, distribute that exponent. So it becomes 4 exponent 2 over 5 exponent 2. 4 squared, right? That's 16. 4 times 4. 5 squared is 25. All right? And we can't simplify that, right? If we could simplify the fraction, we would, but there's no common factor. So our final answer is going to be D, right? The value of the expression x squared when x is equal to 4 over 5 is 16 over 25. Okay, all right. Let me read this. So, while experimenting with a toy rocket, Dan determines that he can model the rocket's height, h, in meters with respect to time in seconds, using the equation h equals 1/2 t squared. Right? So meaning that he a certain time after he launches the rocket, right, 2 seconds after he launches the rocket, he can substitute in the value t and then get an answer for how high the rocket would be. Okay, so which calculation correctly finds the value of h when t is equal to 10? Okay, so why don't we go through and see? Okay, so we have A, B, C, and D. All right. So it appears they all start off looking the same, right? 1/2 times 10 squared. 1/2 times 10 squared. Okay. So essentially, it looks like we're looking to find the one that properly uses the order of operations. All right. So I can see the mistake that was made in question A. Can you guys see it? Right? Remember, what's the first thing we should be dealing with? It's the exponent, right? But that's not what happened here, right? This person incorrectly divided 10 by 2 first, right? So what they did is they did 1/2 times 10 all to the exponent 2, right? That's what they did, which is 5 squared. And that's not correct, okay? That's not following the order of operations correctly. Okay, let's look at B, okay? All right, I can spot the mistake in B. Can you guys? Well, it's pretty straightforward, right? So they're saying 10 squared is equal to 20. Well, that's not right, right? That's not right. 10 times 2 is equal to 20, but 10 squared is 10 times 10, which is not 20. Okay, so let's move on to C and see how that goes, all right? So we have, oops, let me just grab this. Here we have, okay, so what do you guys think? Do you see a mistake here? I see them, okay, so the first thing they did was they did the exponent correctly, right? 10 squared is 100. And then they multiplied by 1/2. Okay, so C C actually looks like the correct one to me. Okay. Now let's see about D, just to make sure, right? All right. Well, again, I see a mistake here, right? They go from times 1/2 to times 1/4, right? So what they did, oh, I see what they did. They did H 1/2 1/2 squared times 100 squared, right? So what they did is they did this times 100, right? And that's not correct either. All right, so again, that leaves us that answer C is the only one that was done correctly, right? And we know that because they followed the order of operations correctly.